Okay, welcome back. In this video, we are going to be explaining a little bit more what we went over in class yesterday about areas under the curve. And I just want to review with this graph here that I have is f of x, starts at a, it goes to b. And so the blue curve, that's your f of x. We're going to define g of x as the integral from a to x of f of t dt. X represents your stopping point. So if you start at a and you pick any point between a and b, it's arbitrary, it doesn't matter. Let's say I pick this point here, call it x. I would start shading at A, so the area between the curve and the x-axis, until I get to x. Now, x can change. I could have chose x to be over here or really anywhere on this interval, and so that's why we call it x. It's really our stopping point. Because we already used x as our stopping point, we can't really use x again in the expression. Can't say from a to x of f of x. So we just use t. T is really like your dummy variable. It's not, the function's really not in terms of t, but we're using it just because we don't want to use x again. X now means our stopping point. But the real function is actually f of x. So that's what we talked about in class. And what we're going to do now is take a look at some examples of how this works. So we have the first function is defined as h of x is from 0 to x of f of t dt. Here's f of x, so we are going to be finding the area from 0 to x. The first problem says to evaluate h of 0. So we're literally going to plug in our 0, and we're going to get, and I can now use my x, because I now replace x with a number, so x is free to be used here. I don't have to use t anymore. Well, if I start at 0 and I don't move any direction, I'm still at 0. That means I've covered no area. For h of 2, if I start at 0 and go to 2, I'm going to start at 0 here. And if I go to 2, this area is going to be above the x-axis, and we are moving to the right. Because we're moving to the right and we're above the x-axis, that's going to be positive area. It is a triangle, so all I have to do is base times height divided by 2, and I believe that gives us 4. Base times height divided by 2. The third example is the integral from 0 to 3. From 0 to 3, starting at 0, I'm going to count this area that I already found. I know that area is supposed to be 4. And now the area below, let me use a different color. Because it's below the x-axis to the right, that's going to be negative area. And it is a triangle. So I'm going to do 1/2 base times height. 1/2 base times height, that's 1/2 times 2 divided by 2. So that ends up being a 1. Because it's negative, I add the 4 and the negative 1, and that gives me 3. The result is 3. So when you're evaluating this, you got to keep in mind cumulative area. We start at 0, so all that blue stuff needs to be combined with that red area, and that gives you a positive 3. And you just keep going in that format. We're going to now go to negative 7, starting at 0. So again, from 0 to negative 7 of f of x dx. Okay, and so we're going to start from 0 and go to negative 7. That area is located above the x-axis, but it is moving to the left. So it's got one negative factor here, which means this whole area is going to be negative. Whoops, let me use a red for that. And so I just need to compute the area and then make sure that it is going to be negative. To do that, probably the best thing is to divide it into 2 separate shapes that are easy to, let me erase this so you can see it better, that are easy to evaluate their areas. I'm going to draw a line down here at negative 1. So I've created a nice right triangle and a trapezoid. For this right triangle, it's going to be 1/2 the base. The base is 1, 2, 3, 4, 5, 6. Times the height. The height is also 6. All right, so that, of course, is going to give us 18. All right, so I'll just put it up here. And now I need to find this trapezoid. the height of the trapezoid is going to be here. It's just 1. And then the bases are going to be 4 and 6. So that's going to be 1/2 times 1. And 6 plus 4 is 10. So that's going to give us 5. Okay. All right, so the result of that is going to be negative 23. Now, for h of negative 8, we already know that this entire area is going to be negative 23, so we can use that. But we have an area here that is below the x-axis moving to the left. If you are below, that's a negative location, and to the left, that's a negative direction. So 2 negatives make a positive. So this little area is going to be positive. If I find the area, it's going to be 1/2 the base times the height. So of course that's a half. And so I'm going to combine, because I'm starting at 0, I'm going to combine that negative 23. I'm going to combine it with a positive 1/2. And the result is going to be negative 22.5. Or 22.5. Okay? So that's really the whole idea. You need to keep in mind the direction that you're moving and the location of your area. The last 2 questions have to do with mins and maxes. And we're going to talk about this a little bit more when we do Fundamental Theorem of Calculus Part 1. But for now, we're just going to kind of think logically. If we're starting at 0, we want to know what is the most positive area that we are going to get. We know that if I move to the left here, this is all going to be negative. And if I keep going, so this is negative area. And if I keep going, I'm going to get a little bit of positive here. But I know that's not enough to offset the negative. So moving to the left is going to give me a negative result. Now, if I move to the right, I'm going to get a positive result for the first chunk here. But if I keep going all the way to 3, I get a little bit of negative. So that means that as I move from 0 to the right, the most positive area I'm ever going to get comes from this triangle. And if I keep going, I'm not really going to increase my area anymore because this is going to subtract from it. So that means the biggest value that I can get is this area here, and it happens at x equals 2. We've already computed that answer. It's up here at h of 2. So my max value is 4, and it happens at x equals 2. So how about the min? If I'm looking for min, I want to get the lowest y value. So basically the most negative area. Well, I know that that's going to happen as I move to the left. I'm going to have a bunch of negative area here, all the way to negative 7. But if I keep going, this positive is going to kind of cancel out some of the negative. So the most negative area I'm going to get happens at negative 7. And I've actually already computed that over here. It's negative 23 at negative 7. So take a moment, pause the video, go ahead and try the other 2. I'm going to fill in my answers, and then you can come back and check your work with what I have. Okay, so hopefully your answers match mine. I hope I didn't make any arithmetic mistakes. I do want to go over this question here. What is the min value of h of x for this function? If I start at negative 7 and I move to the right, all of this area is going to be positive, right? And then a little bit of negative, but sorry about that. But in reality, I'm going to have a lot of positive area. Now, if I go to the left over to negative 8, because I am below the x-axis and moving to the left, that means that this area is actually going to be positive. So if I move to the right, I get positive. If I move to the left, I get positive. So really, the smallest value is if I just stay at negative 7 and don't move and get a 0. Okay? Now, by contrast, over here, if I start at 2 and I want to get the max value, if I move to the right, that's going to be below and to the right, so that's negative. If I move to the left, I'm going to get a lot of positive. Above and to the left is negative. So basically, if I move to the right, I get negative. If I move to the left, I get negative. And even if I add this positive stuff, it's still just not enough area to offset all this negative. So that means if I stay at 0, that's the most positive area I can get, because anything else is going to result in a negative. Now, before I kind of in the video, I want to go over a couple of your homework problems just to prepare you for what they require. Let's see. It's this one here. So in the first part of your worksheet, just to make sure you're good with this, is going to ask you to do, let me clear this up. It's going to ask you to do the integral, and it wants you to use areas. Now, you could use Math 9 to compute this, but basically, I expect you to graph the function that you find inside. So in this case, that's y equals 5. In this case, y equals negative 20. In this case, this is y equals technically 1/2 x plus 3. So y equals mx plus b could be used to graph that. Now let's graph this real quickly and see what it looks like. Y equals 5. So I'm going to start at negative 2. And I'm going to go all the way to positive 1. If I graph y equals 5 here, and we stop at negative 2 and 1, you can see that that creates a rectangle. So you can go ahead and find that area using geometry formulas. In this case, over here, if I graph this line, it's going to be 3. So I'm going to start at 3. And then 1/2 is my slope, so something like that. And I'm going to go from negative 2 to 4. So, again, you're going to have to use geometry formulas to figure out the area. So just make sure you graph it correctly so that you get those sketches. You get a good idea of that area. The last one that students usually struggle with in the homework is this one right here, because you start to use B's and A's. So keep in mind, B is supposed to be like a number on the x-axis. So let's go ahead and graph this. Remember, this guy is y equals x. So y equals x is going to be the function that goes through the origin and has a positive slope of 1. And if we're moving from 0 to b, what you're going to notice is that that creates an area that is a triangle. So to find this answer is just 1/2 base times height. So 1/2 base, well, the base is just going to be the distance from 0 to b, so that's b. And the height, well, it's dependent on the function. So if I plug in b, I get y equals b. So this is actually b as well. So I get b squared over 2. Now, there's no way to simplify that further, but I have found the area in terms of b. And that's really what's going to happen. Keep that in mind because you're going to have some a's and b's over here. And I switched the variable to s, but it's basically the same thing as x. All right, hope that makes sense and it helps you do the majority of this assignment.